which shows the value of what's happening in New York in particular and how we're going to make that happen within the robotics ecosystem. New York Robotics is about building this foundation in this regional hub here in the tri-state throughout New York, New Jersey, Connecticut, and parts of eastern Pennsylvania. But we're more than just a regional hub and what's happening in the tri-state. We are a nexus, the power of New York, and in particular New York City, as the fastest growing tech ecosystem in the world, and home to Fortune 500s, and home to the United Nations, and home to a really amazing group of people, academics and otherwise, creates an epicenter that we can help power all of what's happening in the nation and propel the industry forward. But not just throughout the country. We can also do that on a global perspective. New York City is a place where people convene on a global capacity, not only through the US, but from around the world. And we're here to kind of help pull that together and make this about what's happening in New York, but also on a global scale. And this is us, this is the mission statement. We're here to catalyze and grow, to support, and to help put this region on the map, but also to help put robotics and make it more important in what's happening in the industry around the world. Today, we're supporting on a number of fronts, particularly within the startups or industry partners, academics, but there's lots of growth to happen. And as we continue to grow, we have a model of how we're going to do that and the growth across different stages. This is still within year one of our development, and we are here and doing really exciting things already. And we're doing all those things with our various partners, our founding partners in particular. You see on the board some of them we share with the New York Tech Alliance, which is really exciting, particularly Eisner, Amper. Where's John? There we go. Additional support from a lot of teams from New Lab, Tech NYC, Ally Corp, and we wouldn't be here without all of our partners or advisors, the people that help us throughout the day. And my team. I called out Randy, probably not in the room, Arkel and Fady, also our founding board members. Shayla and Seth and a bunch of others are already also here that are volunteers and support. If you are interested in supporting us, working with us, volunteering, please see me or Randy or Shayla, and we'll help you get aligned with that. And most excitingly, you were the first to see this. This just happened in the last hour. We are excited to announce that we are partnering with Frog Design, the world-renowned industrial design, engineering, marketing company, to launch a robotics-focused Frog Tank, which is their series to support startups and small businesses moving forward through the power of design and what Frog offers. So this is the QR code to fill out. You're the first to have access to it. It will go live later this week, so no guarantees on the order that you're getting in there. But this is a really exciting movement forward in helping to kind of bring the power of design into what's happening within the robotics ecosystem. Everybody got it? Still see some phones. We'll come back to it. But without further ado, I don't have a slide with all the speakers. Stand by.
We're going to switch it up just a little bit. So AJ needs to cut out of here to go to a very important meeting, and we're going to allow him to go up first, and then we'll follow with Journey Robotics, okay?
We're going to restart this? Or do you want to go all the way through?
Just click through to his.
Okay, everybody close their eyes. There we go.
There we go.
Without further ado, AJ Meyer from Pickle Robotics.
Yeah. Super. Okay, great to be here. I'm AJ Meyer. I'm the founder of Pickle Robot, a 6-year-old company out of Cambridge, Massachusetts, physical AI startup. And there's a lot happening in physical AI, embodied AI. We'll converge on language eventually, including this event and some of the other great ones being organized by our sponsors here. So let's thank Jacob and the New York Tech Alliance. Anyway, in the first 90 seconds here, I'd like to introduce you to one of the first products in this category that is starting to achieve some real traction with customers and starting to scale value into a very specific problem in the supply chain. And here's some of our customers. So let's just take 90 seconds and see the product.
Pickle Robot. Pickle Robot.
All right, that's enough of that. Oh, great, thank you. And so now we'll just put on some background material while we chat. Look, there are tens of thousands of warehouses in the United States. There are hundreds of thousands of factories. And there's over 1 million retail sites. And what they all have in common is this kind of universal interface between them at the dock door, whether you're loading or unloading. It's kind of the universal portal that connects all these things. And every one of these buildings has kind of 3 steps. It has an inbound process, which is what you're looking at one of our customers in Texas, a Fortune 50, incidentally. They've got a middle of the building where it does whatever it does, sort packages, fulfill orders, manufacture something. And then it usually has an outbound process where you ship the thing out. And so this may look simple, but what you're looking at actually is very much at the frontier of robotics. We're probably 50 million in R&D to get this far, and most of that is just in the last 18 months. This AI, it's physical AI, has to make hundreds of decisions every second. What box to reach for, how quickly it can move it without dropping it. It has to guess about things like the weight and the depth that you can't necessarily see. The boxes can be 60 pounds, which are incredibly heavy and hard to move around. Where do you drive next so that you can reach a lot of boxes? When to drive? And making these decisions, you have to distill down from an awful lot of data. It's a huge mess. We have 7 RGB cameras and 2 radars, 2 LiDARs. We look at motor currents in the arm. We look at touch sensors in the hand, suction-based grasping in case that wasn't clear. And so, fundamentally, the problem is this. You start with all that data, and what you end up with is you need to deliver the KPIs that the customers expect of you, which is 600 pieces an hour, or it's 2% drop package rate, or it's 98% uptime, or it's some other thing that lets you integrate with the whole rest of the network downstream of you. And I know that in the news, like maybe the more exciting piece of robotics is humanoids, but I happen to think that as inspiring as C-3PO was, he is the comic relief of Star Wars, and the one that does all the work looked more like a trash can. And my favorite robot from the movies is Wall-E, who was a trash can. And figuring out how to take products like these and stitch them together into systems that deliver actual value to customers and meet KPI is fundamentally the goal and the hard problem of this moment in our industry. So if you're working on anything, is it time to make my ask, or we switch to questions? Oh, great. So if you're working on anything that you think goes on inside of these buildings with physical AI, I'd love to talk with you and figure out how we might connect our systems together. We have the doors, and hopefully there's something else going on that you're working on inside. And if anything I said sounds interesting to you, we are also hiring like crazy. We're 100 people now, and we'll probably be 200 in short order. So thanks very much for your attention. It's great to be here. Yep. Oh, I do. And they clicked it for me? Now my button doesn't do anything. Okay. You can just visit picklerobot.com and yeah, get what you need. I do, yeah, Q&A. It's great. Let's do it.
Raise your hand if you have a question for AJ.
Just a simple question. Were the boxes that we were just watching the demo filled with stuff?
Oh, yes. Some of those boxes were 55 pounds. That was at a customer site in Texas. Yeah.
Thank you.
Customer that's done quite a lot of business with us. Yeah.
Yeah, so my question is on scaling the business. So what are the most challenging aspects of scaling business in a vertical like this, and how did you guys address it?
By far the most challenging aspect is making it work and recognizing that you in the truck, whether you're loading or unloading, are not totally in control of that. We call it the back of the robot problem. So thinking about what happens just downstream of you or just upstream and really understanding that problem from the customer's point of view is the hard part. I'll just give you an anecdote that helps lay that on really thick. Our first kind of field pilot robot from 2023 had a product requirement in its design that we thought was tautological, which was that you can get your payback, which your ROI, as long as you can keep the thing busy enough to unload 2 trucks a day. So if 2 trucks a day are coming in and the robot is compatible with those 2 trucks, all steam ahead. And the customers believe that too. Turns out that was not correct. If you zoom out on the whole building and really understand the process, the real metric we should have been chasing was we can support 50% of the freight arriving into your building. It took us a whole year to fix that problem.
AJ?
Yeah.
I have a question about the tech part. What type of vacuum generation do you do, and how do you deal with when half the vacuum is off the box, not losing your suction?
That's a great question. And maybe we don't want to spend too much of the audience's time on something niche, I guess. But getting a robot to pick up 60 pounds from 9 feet over your head was not so easy. It's a 3,600 RPM blower motor, the same type of thing that they used to blow up the tennis courts in New York during the winter, if you see those giant bubble domes. And we definitely do leak air through the open holes, and figuring out how to mitigate that has been a lot of IP for us.
If you're going to ask a question, please stand up so we know who's in order. So if you have a
AJ,
Yeah.
thank you for the presentation. It was
Yeah.
great. The video, you see a lot of moving parts.
Yeah.
Robots are fun to look at.
Yeah.
Where's the physical AI?
Interesting question. So the way I like to answer this is thinking about, I have a new son, 18 months, and I take a zillion pictures of him all the time on my phone. And, this is really a camera for me. This isn't my old point and shoot, that we've made more sophisticated by adding a bunch of processing and running apps on it. This is my laptop that we have shrunk down and added cameras to. And that may sound subtly different, but the robot is the same. We started with an AI server, and we started bolting stuff onto it. Motors and wheels and sensors and other things, but at its core, it is a computer. It's not like we started with the robot arm and then added a computer to that, if that makes sense.
Hello. So I was wondering how, when you were building the robot, I first identified any problems, and then from there figured out how to fix them and what to do moving forward.
Yeah, well, one of the things that we learned the hard way, because a lot of us started in academia and research and frontier tech, is that making a successful product is as much about testing as anything. And boy, do we do a lot of testing. When we chose our new HQ facility in Boston, the thing that was hardest for us to get was dock doors, because it's hard to find loading docks inside of the city where you're close to MIT, where all our talent base is. And we found the one building within a bike ride of campus that had 20 dock doors in it, and that's the one we leased. It all just comes down to how much volume can you run through the thing so that you can really test and then surface the issues and then solve them.
Hey AJ, I'm over here. Thanks for sharing your presentation. You mentioned $15 million of R&D in the last 18 months. Can you break down where that money went? And then you mentioned that you're doubling. What are the primary roles you're hiring for besides AI engineers?
Sure. So I wish it had been 15. I think I spent closer to 50. And yeah, we're hiring across the board. I think all startups go through, particularly in frontier tech like this one, this transition where you spend most of the money on engineering and research in the beginning, and then it kind of becomes more and more sales and marketing. Right now, we're probably 50-50 core engineering and technology work and product versus sales and product operations and manufacturing. But I think there are roles open in every division of the company.
Hey AJ, I have a question for you. First of all, thanks for sharing your amazing result for your company. And knowing that warehouse industry has been such stable, maybe single digit, I assume, and you've been working on this space for the past 6 to 7 years, what are you been seeing for the trend as the stable that for your product development, and what have you been seeing hugely change versus the first day you've been into it?
Yeah, the biggest thing that has changed since we started is the market itself. Guys that operate logistics plants for a living are all in market now in a way that they weren't before. And I think we chose wisely. So they did a survey this year related to warehouse operators buying automation, and 40% of everyone surveyed said they wanted to buy load and unload robots. That was not true when we hung a shingle. And I also think, dare I say in front of a room full of some investors, it's a little premature. We're finding that we can create value for that initial set of customers to get our toes in and create a market leadership position, but this is incredibly hard. And I think the most important question to ask when you're either starting a startup or investing in one is, do you have the timing right? Are you within a 4 or 5 year window of actually being able to solve a problem at scale for customers? And I think we got that just right, but also just barely. Okay.
One final question.
So how do you see competition in this space? So there's, I think DHL just placed an order for 1,000 robots from Boston Dynamics.
Yeah.
There's also NY Robotics, who has a very low cost, very similar robot. Seems like at the Automate show for logistics, they all look somewhat similar.
Yes.
So how do you view the competition, and how do you stay as the leader?
Super question. And I was making a joke to a friend of mine the other day about talking about competitors, and I said, you could publish all of your secret plans, and this space changes so quickly that the competitors don't even have time to read them. So everybody kind of made their bet, and they're all running their own race. Now, our biggest competitor in the dock door is Boston Dynamics. I'm quite proud of where we sit next to them in the market. We have our own 1,000 robot deal that's maybe not as public as the one with DHL. But the way that we've tried to go about creating differentiation for us was to really focus on the autonomy and physical AI component. The robot itself is made from off-the-shelf parts. And what that lets us deliver for our customers is reliability. And if you're busy 5-axis milling your own motors, you're gonna have to ship the prototype with a support container and a bunch of mechis, and just keeping the thing running is hard. If you're running a Walmart distribution center that costs $1 million an hour, the equipment that goes in there needs to have an extremely high uptime and extremely predictable reliability. We've inherited that from our vendors, whether that's for our current product, like KUKA is a great vendor with very predictable results, or like our investors Teradyne that have in their UR product something that's very predictable and reliable with spare parts and a large ecosystem to keep the thing running. For me, that's, the physical AI is table stakes of making it work, but the reliability is how you win deals. Okay, thanks so much. Fun being here.
Nope, sit down. Thank you. I'm asking you to sit down because I also want to ask all the folks that are standing in the back here to come inside here and take a seat. There's plenty of seats on the far side. Make it a little bit more comfortable. I also know that you're staging for when the food comes out later. I understand. Perfect. All right. Now, I would like to invite Kyle Solomon from Journey Robotics to the stage.
All right. I follow. Let's do it. Awesome. Thank you, sir. Got it. Hi, everybody. Good to see everybody. I think you're actually going to hear a lot of familiar things that you just heard. So I am Kyle Solomon. I am co-founder at Journey Robotics. Despite spending a ton of money on ground handling labor, commercial aviation is struggling to meet demand and profitability. And it's really around 3 areas: labor shortages, service issues, and antiquated and inefficient infrastructure. So what we're doing at Journey is we're revolutionizing aircraft ground handling services, and we're starting specifically with one of the market's biggest pain points, which is baggage handling. So I'll ask you a question: who has traveled and ever had problems with a bag as they were traveling? I think most of us would raise our hand. There's like 60 million bags at any given day that are flying through the air. Damaged, lost, deformed, you name it. That's what happens, and we're tackling that problem. We do it similarly to Pickle in a sense that we build our own hardware, we build our own tech stack, but similarly, we rely on partners. We don't need to recreate the wheel on a lot of things. So we have partners that give us the reliability, that give us the shelf life, that get us to market faster and at competitive pricing. This is our baggage handler right here. So it's a patent-pending end-of-arm tool. You'll see it, suction. We're able to grab bags in really tight places inside the baggage room and inside of carts. We use next-generation AI computer vision. The big deal is that we're actually a drop-in solution. So that's big for airports. We don't change infrastructure. We can pick up bags that are up to 70 pounds. And we do it at 8 bags per minute. So the question I always get asked is, okay, 8 bags per minute, well, what do humans do? Humans do 10 bags a minute, but as we know, think about throwing 50 to 70 pound bags all day. You would get tired. You wouldn't want to come to work. You would want to take a break. you would get injured. And that's where our solution comes in. So our baggage handling robot uses a deep learning network to detect and segment the bags. It identifies important features on the bag, such as wheels and handles. And if you think about bags, they're deformable, different sizes, different weights. They sink into each other. It's a hard problem, right? It's a very hard problem to solve. So our robot will then optimally determine and pick the location and orientation. And then we just store those images on and the performance data around the robot. So we incrementally keep learning as we collect new data day after day. So this is us. We're now inside Pittsburgh International Airport, where we're testing in a real live environment. This is our test bed. This is what the computer sees. This is what the head sees. So picks the bag, understands where to actually then go in and place the head, right? Goes in, uses that vacuum technology, front facing, to pull it onto a lever and then turn it and place it on the conveyor belt. This is what it looks like actually inside Pittsburgh International Airport. So we're grabbing the bags from the front of the face. That's different technology, a very hard technology to master. And it allows us to load and unload full carts, also a big deal for the industry. So you might think we've been around for a while, but we're only 18 months old, which I think speaks very highly of the experience and execution capabilities of our team. So, like I said, inside Pittsburgh International, real live airport testing, that was in April. 2 weeks later, actually, we were demoing at the World Innovation Summit at Pittsburgh International in front of 80 industry folks, airlines, airports, channel partners, and got amazing feedback. So it's incredible when people see videos and then actually see it in person working, the feedback that you get. We're going to be in there at least until September. We'll do some beta refinement, and then we're going to be in beta trials here by year end. We're shooting for 2 or 3, and we're already talking to airlines and airports, both in Europe and in North America. As you know, you can't do it alone, so we have an amazing team. The company is based in Pittsburgh. So we have some CMU-based founding members that have been doing AV. There you go. Give it up for Pittsburgh and CMU. We've been doing aviation for at least 5 years, but have been in robotics for 15 and 20 years. And then industry and technology partners. Couldn't do it without these folks. So both from the hardware side and from the network. And we're getting great support here in New York also from New York Robotics Network and Tech Alliance. So we really appreciate all of that. And with that, I will stop and take questions.
Hi, thank you so much. Great presentation. You're currently at 8 bags a minute. What do you expect to get to in the next 2 years, let's say?
So there is a cap on how many bags you can pick, right? So I think eventually we can get to 10 bags, right? So we'll be equal to. But if you look at the conveyors only run at a certain speed. So you can get up to 12 only, and then it gets crowded. So spacing is really important. That's something we figure out. And by the way, we don't have to be exactly equal to humans for all the reasons that I mentioned. We get to work longer, 20 hours. Right, typical automation. Dirty, dull, and dangerous job that nobody wants to do anymore.
Hi, forgive me if this is a little left of center. I'm curious if you're, sort of tracking damage rates. I mean, because there's damage that happens with humans as well. But the reason I'm asking is that I don't know if you're aware, but there's about 1,000 wheelchairs that get damaged every single month, almost 12,000 wheelchairs a year. And I feel like there is an opportunity, if it is slower, to actually maybe be better than humans when it comes to wheelchair handling. So anyway, those are 2 questions that I have.
Yeah, and I agree with that. So it's a great question. So our robots absolutely handle bags a lot easier, right? The bar is pretty low, right, for us to match. But I would say this, we're focused on sort of the 80% of the baggage that comes out of the plane. There's always going to be special handling like wheelchairs or skis or golf clubs or fishing rods. We'll get there eventually, but for now our focus is really around the 80%, but agreed, there definitely needs, that is some low-hanging fruit that needs to be looked into.
It's an opportunity area. So
Correct.
Anyway, thank you so much for your presentation.
You got it.
Thank you again for the great presentation. I was really curious about how you test a robot like this, especially with the diversity of bags that probably exist out there in the world. And I think you mentioned this is a drop-in solution, so you have to be able to, I guess, deploy it in any airport.
Correct. So no change or limited change to infrastructure, a great selling point, right? And by the way, we're starting with unloading, so we don't have big integration with the airport. Bags come to us, we pull them off, we put them on the cart. Those bags that you saw, by the way, are fully loaded. Those are like 50 and 70 pound bags. They move, they shift, they melt into each other. And so it was a really hard problem, but we've spent a lot of time around bags, and that's where we came up with the front loaded vacuum, right, that pulls it onto a shelf and then gently but quickly moves it and puts it onto the belt. So really focused on that, and not a ton of competition. So there's maybe 3 or 4 other companies that are looking at this currently. Most of them are doing loading, which is fine, a much harder and complex task. We're actually looking at unloading for the reasons I mentioned. Allows us to get in quicker, and that's really then our admission ticket because we can do loading inside and outside.
Thank you for presentation. Sorry. Thank you for presentation. It's a wonderful solution, and hence the question is like, what is the main challenge you have right now?
Well, I think the main challenge was understanding bags. So we've gotten that down, and being able to use embodied AI has been incredibly helpful. That data again and again and repeating it. I think it's also market adoption. So like anything, one of the questions we get asked is, you're replacing humans. And the answer is no, we're not. We're augmenting human labor. We're making the workplace safer. We're allowing workers to potentially upscale and maybe then come and work robotic stations instead of throwing around 50-pound bags all day, or go somewhere else in the airport that's equally as important but not as body damaging, right, to help with labor elsewhere.
Yeah, 2 questions. With a drop-in replacement, how do you, are there any concerns around human safety around that? Does that need to be fenced off? And then also, if you can't do 100% of the bags, like what's the solution? Does it like move on to a human or something like that to finish the cart?
Yeah, so back to that point, there's always probably going to be a human in the loop here, lifting up the curtain, maybe picking up a bag that dropped before we could pick it. And then what was your first question? I'm sorry.
The safety for people.
Oh yeah, the safety.
Robot.
So you saw on their SICK, S-I-C-K, 6 sensors, right? We're using their safety system. So we will cage, right? But we'll also use a sensor system so that if anybody walks into the space, it immediately shuts down. So very cognizant about safety, for sure. Thank you. I'll say this before you kick me off, because you wouldn't let me come up immediately. So our ask is that we are raising our seed round, right? And we're going to be raising somewhere between $3 and $4 million. So if you're interested in helping us to solve the problem, we'd love to have you on board, and we can meet up after and chat.
Less of a clap about money. All right. I'll wait till you're seated. Respect. Guess who's next? Anya Zorin from NYU, General Purpose Robotics and AI Lab.
I'll stay up here. Hi, so I'm Anya. I'm a research assistant at NYU, and I work on robotics and machine learning. This presentation is going to be a little bit different because it's going to be about research rather than, well, I'm not representing a company. It's going to be about my most recent research project where I built a robot hand. So to give you a little bit of context, I work at the General Purpose Robotics and AI Lab with Professor Laurel Pinto. And our broad kind of goal is to get robots to generalize and adapt to the messy worlds that we live in and get them to seamlessly integrate into our lives. So I work on robot hands, and kind of the first question you want to ask is, why hands, right? Think about the two presenters that just went. They're not using hands. If you look at most robots that are actually being used, none of them have hands. Hands don't really work right now. But, like, you know, our human hands, they work great. And we can do lots of dexterous tasks, and so should robots have hands? And I think the answer is yes, because the world is built for humans, and it's built for human hands. So if we want to, without having to change infrastructure, drop a robot in and use human tools, we want robot hands. And so that's what we did. We built a hand that can actually interact with, you know, human objects. But why are we building a hand as a research lab? You know, we could just buy one. There's commercial options available, but the ones that we were using had a lot of issues. So the other hands that we were using were either too big, like in this photo, they're not really human-like, they only have 4 fingers, they're really hard to repair, they would break, and then we would have to send it somewhere for a whole month. And also, they're really expensive, they can cost up to $200K, and not everyone can afford that. And if we want to have research move forward and finally get to dexterous manipulation, it kind of needs to be accessible. So that's why we made Ruka. And Ruka, the goals were to have it be human-sized, dexterous, easy to repair, and also have it be a low-cost robot. So the way that we went about this is we made it easy to repair and accessible by making it open source. It's fully 3D printed, everything's available online, our code, our files, and the assembly instructions. It costs around $1,300, and most of the cost is just the motors. So we also made it human-sized by making it tendon-driven. So instead of having the motors in the hand itself, they're displaced into the forearm, like in the photo, and this way you can have a really small, compact size. And so the low cost, obviously it's 3D printed, so it's pretty cheap, but also there's no electronics in the actual hand itself, it's all in the forearm. This means that there's no sensors or encoders in the fingers. And you know, this is what usually adds a lot to the cost. This is also what breaks. And they're there for a reason. It's because that's how you know what state the robot is in. That's how you tell the robot, okay, close and like move to this exact position, pick up this object. So this kind of means that our hand is hard to control. So how did we work around this? Because in the video, clearly we were controlling it pretty well. We used data. So we took a motion capture glove that's meant for humans and we put it on this robot hand. And then we basically did a bunch of random motions, and we took the motion capture readings, which are the fingertip positions, and we also recorded the motor positions. And with these readings, we were able to learn a model. If you give it 1 second, the model will pop up. But there we go. So we learned this model. It's a sequential model where you can input your desired fingertip position, and it'll output the motor positions the hand needs to go to get there. And so using this, we got pretty good results. We can, you know, handle human tools, do some cool stuff, use the saw. We can also take off this Nutella cap, and there's lots of more videos doing all this. But yeah, so that's kind of the project. It's a research hand. It's not exactly a product, but it's meant to be accessible and to move it forward so that eventually in industry we can actually use hands. So my give is, it's a fully open source hand. If you scan the QR code, it'll be our website with all the instructions. If you want to build it just for fun or as research, please go ahead. The assembly instructions are also all there. And the CAD files are fully editable. Thank you, and I'm opening up for questions.
Thank you for the presentation. My question is on full autonomy. So some of the videos, for example, uncapping that can is pretty impressive, but it's also teleoperated. How should we move towards full autonomy for complex tasks like that?
Yeah, so we do also have some autonomous policies working. They're mostly for kind of simpler tasks than opening it. Obviously, this is an open area of research. So there's a lot of arguments on how exactly can you have like fully embodied AI. And so what we usually do is we do some kind of either imitation learning or sim to real with like online fine tuning. But if you want to talk more about this, feel free. I'll be at the table. I'll also be doing a teleoperation demonstration because I do have the hand here. Yeah.
Hello.
Hi.
Hey, great presentation. This is all from carpal tunnel, so my hands are struggling. Can you tell me about integration with prosthetics or anything, or maybe people with maybe they have a thumb but not 4 fingers? Like, how does the tendon drive work?
Yeah, I think, so I did look into prosthetics at one point. This isn't designed for prosthetics mainly because the motors are all in the forearm. In prosthetics, you have different design priorities, right? You want it to be really light. You want it, people don't always necessarily want full dexterity like in this hand. So this isn't really great for prosthetics. I think some of the ideas about how to control it are good for prosthetics because you can imagine that this machine learning model, instead of one of the ends being motor positions, you have EMG signal. So it could be good for controlling, but maybe not the hardware. Thank you.
Hi, so this wasn't integrated into this design, but I still want to hear your take. A lot of these companies working on robotic hands have sort of skirted around integrating tactile sensing, and I see that a lot of them have moved towards, as a workaround, using just cameras because that's already in their design, so they could just use the camera information for grasping and the such. But I'd like to know what your take is on how important tactile sensing is for the future and direction of robotic hand development, and what would be the best differing factor between getting that proper tactile sensing and sticking to that, what I see as a short-term solution, using visions and cameras for replacing that, at least for now.
Yeah, I agree that vision isn't enough. So we are already working on integrating tactile sensing into the hand. I think that in general with manipulation with hands, if you think about how us as humans use our hands, we're not looking at everything we do. So I think tactile is very important. It's also one of those things that people haven't exactly figured out how to use tactile data yet. But I do think that is what's going to maybe solve dexterous manipulation, is incorporating the use of tactile data.
Thank you.
Yeah.
So I have another question. It's a constant debate in robotics whether it's a problem with intelligence or with the hardware. So how do you decide if, given a task, is that just not enough AI or not enough hardware?
I think usually it's a combination, is what I would tentatively say. I think it's usually clear to see if we try and evaluate the hardware to know that the hardware is technically capable of it. And that's what we do with this hand is, there's lots of research done on what makes a hand dexterous. There's all these grasps you should be able to achieve. We make sure that we can achieve those so that we hope that this hardware is good enough that it can achieve everything a human hand can. And from there, it's the role of the AI to actually get us the rest of the way.
Hello. So I know you said that all the motors and wires are in the forearm. So I was wondering what types of motors and wires you used in the hand.
Yeah, so we use off-the-shelf servo motors from Dynamicsil. They're, often used for hobbyists, and they're quite nice. For the tendons, we use braided fishing line. It's technically rated for 200 pounds. Again, the goal of this hand was to be accessible, so everything you can buy either on Amazon, McMaster, it's all very easily available to everyone.
One last question there.
Thanks for your presentation. I'm just curious, you made this open source. What are your hopes that people would do with the adoption of this technology?
Well, I'm hoping that, so we already have talked with a lot of other research labs that are already building it, so it's mostly meant as a research tool. I think that not enough people are working on dexterous manipulation, and hopefully this will bring more people in. And the other thing is just, it's also partially came from a frustration of looking at other open source hands and I couldn't edit them. So I made sure that you could edit this so that you can, if you want to add your own tactile sensors or you want better motors, you can easily do this. Yeah, once again, the ask is, all our information is on our website if you want to build it. If you have access to a 3D printer, you can do it. So thank you very much.
All right. Do you want to make a do a thing now, or do you want to do it afterwards? All right, then next to the stage, Heighten Sonpaul from NY Robotics.
Let's try this. My name is Hiten. I'm with NY Robotics. We are automating and electrifying heavy machinery. And here's the clicker. A quick brief on our traction till date. We've raised over $9 million. We've generated over 9 million revenues. We've raised over 24 million that's been put into R&D into the product, and we have over 20 patents. We have partnerships with Gates Corporation, the Air Force, Danfoss, and Anthony Liftgates. And the problem we're solving is bringing dirty, legacy heavy machinery into the present. So legacy heavy machinery is outdated, inefficient, dirty, and dangerous. There's a huge cost to the diesel consumption that happens. 88% of the fuel that's consumed is wasted because only 12% of the energy in the diesel actually goes to doing the work. In addition, 500 million tons of carbon dioxide is emitted by heavy machinery every year. And this is almost worse, 100 million gallons of hazardous hydraulic oil leak into the environment. The challenge with modernizing this and converting this to electric machinery is the inefficiency of the system. The 88% inefficiency of the hydraulic systems means that the batteries for these machines have to be huge, and therefore it makes those electric machines unviable. And our solution to this problem is a new technology that we've invented that we call beltronics. What we've done is we've taken the oil out of hydraulic systems and replaced them with belts and pulleys, and ended up with something that's 3 times as fast, 3 times as efficient, 80% of the weight, and is autonomous and electrification ready. Here's a comparison table. So if you build a system with diesel and hydraulic systems, and you look at the diesel energy on the side, only 12% of it goes to useful work. If you decide to build a battery-powered system, 30% of the energy goes to useful work, but 2/3 of the energy is still wasted. So your batteries are 3 times as large as they need to be. The current alternative for hydraulics are screw-type actuators. They don't have the force, the shock tolerance, the speed, the length requirements, and they end up being very heavy and are expensive. So they can't really be adopted by these heavy machines. And our technology, as I mentioned, is fast, efficient, lighter, has half the operating cost, has no fluids, so the maintenance is a lot easier, and it's 100% digital. So you know right out of the box the position of these actuators, you know the forces being experienced by each of these actuators, and you also know the health of these actuators, so you know when you have to maintain them. These systems are also very strong. In partnership with the Air Force, we recently built a material handling unit prototype. It was awarded the world's strongest robotic arm by the Guinness Book. That's our open house, and that's a picture of it lifting a Ford F-150 Lightning truck. One of the things that we're doing is taking our product to market through partnerships. So we have a partnership with Anthony Liftgates where we've developed a liftgate. These are things that go on the backs of trucks that deliver heavy equipment. This equipment is typically loaded on a dock, and then it's delivered at ground level. So food and beverage companies use this a lot to deliver sodas every day to all the stores in cities. And our liftgate results in $22,000 a year of revenue increase with a 6-month ROI, simply because of the speed and the efficiency and the low maintenance of the system. We intend to electrify the entire $600 billion heavy machinery market. We're starting with liftgates and also launching components, which I'll give a demo of here shortly. And then we intend to tackle forklifts and then work our way through the entire $600 billion verticals. Our future use cases are really interesting. So one of them is perpetual unloading machines. Perpetual motion machines are not a real thing, right? They've been disproven. But our machines are so efficient that when they're unloading something, they recharge the battery. So we're 75% efficient when we're lifting something, and another 75% efficient when we're lowering things. That's a 50% efficiency round trip. So if the item that we're lowering happens to be even a little bit heavier than the end effector that's moving up and down, we're constantly charging the machine. That means the machine's battery size can be tiny because it's being powered by the thing that it's unloading. So a typical use case would be unloading a container ship. So the energy to unload the containers was already loaded when the containers were put on the ship, right? Very exciting use case. In addition, we enable autonomous systems. As I mentioned, you get all of the information about the actuators out of the box, including orientation. That's key to building the digital twins you need to operate these machines. A novice operator that's operating an excavator can make a mistake like lifting too much in the bucket and then tilting the bucket to an angle that makes the system unstable, and then the system flips over. That's a safety issue. An AI system can do the same thing, but with our actuators, we give the AI system the direct feedback it needs to build a safety case and make sure that the system is not going to tip over. That's just one example of building the digital twin. And then those digital twin enable the collection of data. So companies can figure out which actuators in the field are being used more, and if they're over-designed, and if they can save money there, and which actuators are breaking in the field more, and if they're under-designed and need more investment. One of the things we're launching is our cylinders program. I have a cylinder demo here that I'll cover afterwards, but in the second half of this year, we are selling these cylinders to OEMs that are interested in converting their hydraulics machinery to fluid-free. I'm the new CEO of the company, joined a year ago. The founders of the company, who went to school at MIT and the Rhode Island School of Design, brought me on board to commercialize this technology. I've been with the company for a year, and we are launching all of our products in the second half of this year. And with that, let's set up and do a demo. We'll need to switch the cameras around, so it's going to point backwards, so you'll see it here in a second. Rohan, you're up. So that system operates at 2 meters per second, and that is significantly faster than any hydraulic system that you could build. It's also very precise, as you can see from the smoothness of how it's moving. Afterwards, I'd like you to come out and try the system for yourself and see what it feels like. We have a round open currently. We're raising between $5 and $10 million. $2 million of that has already been spoken for. So if you're interested, please see me afterwards. Thank you. I'll take questions.
For compliance for shock loads in material handling or for construction environments, how do you do your compliance, your serial compliance, and what shock values can you handle?
Yep. So when you think about the three different kinds of actuators that I described, the hydraulic systems generally have all of compliance. So what happens is when you experience shock, the hoses and stuff, they expand. The fluid is also fairly compliant. When you use screw-type actuators, they have metal-on-metal contact, which damages the screw-type, so they can't handle the shock. And since our design uses belts on metal, we actually also don't have metal-on-metal contact. So the shock path has plastic and metal contacting, and there's enough compliance in the system to be able to handle shock.
If you're holding the microphone, it's a magic wand that means you have to be standing.
Earlier you mentioned that you used very small batteries, so I was wondering what voltage are the batteries that you use?
That's a great question. So generally speaking, for most electric actuators, the battery voltage is driven by whatever the system voltage is. And so we would just source a motor. We've run 48-volt systems, 24-volt systems, and all the way up to 800-volt systems. So we can support all of them. It's just picking the right motor. Good question.
Thanks for the presentation. Great idea about the container being a use case. But for, let's say, the containers aren't that heavy, like, for example, a typical mom-and-pop loader or something like that, how long would it take for them to recharge the system, since this would be draining, and how long can it run for?
Yeah, so as I mentioned, the actuators are roughly 3 times as efficient as hydraulic systems. That's just at the actuator level. At the system level, you have other things going on. We're roughly twice as efficient. That means that the battery size can be half, or your fleet size can be half, because you're not idling your fleet while you're charging. And not only that, the size of your charging infrastructure can be half, and the amount of investment you have to make in your distribution system is half, and the amount of energy that has to be generated is halved. So we're solving the problem at the edge where most of the energy consumption is happening, and there's a ripple effect all the way downstream to energy generation.
Hi. I was really curious to see that thing working, and I had trouble imagining how it does it with belts. I was wondering if you have an illustration.
Yeah, so before hydraulic systems existed, most heavy machinery was operated using rope and pulley systems, right? So steel cable and pulley systems. What's happened is that that technology hit a ceiling, and then the hydraulics technology just sort of took off. And we believe the hydraulic technology has hit a ceiling, and this new belt technology, which is now being used to replace steel rope in elevators, because it's so durable, it lasts the life of the building and is safe, and is also very compact. Like the previous speaker, we were inspired by nature, so we looked at how humans move things, and humans don't really use fluids and compression to move things, right? So we use fibers and tension, and that's why we decided to go with that approach. So you just imagine belts, and instead of cable, imagine pulleys, and then instead of cables, imagine belts.
One last question.
Okay. Hi. My question is more on like maintenance and like maybe after sales support. Like compared to hydraulics, how frequently do you have to do it? And
Yeah.
How
So
easy is it?
This is a really interesting question. So generally speaking, when you are maintaining a hydraulic system, in the past you would have reactive maintenance. You'd have a hose that bursts or a valve that leaks and your system isn't operating anymore. So then people moved on to preventative maintenance, where you're still spending more money than you need to spend because you're constantly looking at the system even before it breaks and making a decision to do preventative maintenance. What we enable is on-demand maintenance. So the belts have steel ropes on the inside. And what we do is we put electricity through those steel ropes. So even before the belt breaks, we understand that the electrical property of the belt is changing, and we can tell you that it's time to replace the belt. That is the only wear item. And once we tell you that it's time, the next time you have scheduled downtime, that's when you would maintain the system. So not only do we last longer, roughly 3 times as long as most hydraulic systems, but also you don't have to do any preventative or reactive maintenance on the system. The system will tell you it's time to service me. Thanks.
It'd be fun to announce it. Do you want to tell people what's going on? They teased me with lifting an F-150 out front here with one of their systems, but I couldn't get the permits. All right, next to the stage, Nilesh Surirachi. Did I do it right? Close enough? All right.
Awesome. Let's try to do it from here. Great. So thank you, Jacob and Doug, and good evening, everyone. I'm Nilesh Surirachi, and I'm the head of applications engineering at Sientis. It's probably a new name for a bunch of you. So Sientis is an internally incubated venture by Nokia. We're actually based in the Nokia Bell Labs premises in New Providence, New Jersey, so pretty close to here. Unfortunately, we don't have the space to do a live demo here. We need quite a bit more space for that with our drones, so I'm going to steal some of that demo time back and talk to you guys a little more until you get fed up of me. So let's start by looking at the problem that we're trying to solve. So we're completely in the warehousing space. If you can picture a warehouse, this is hundreds of thousands of square feet where there's product coming in and out every day, thousands of boxes being placed all over the place, mostly by humans, and those humans tend to make mistakes. So over time, where that warehouse products are gets distorted very rapidly, and inventory distortion actually costs the global retail industry up to $1.7 trillion every year. That's 8.3% of the actual sales. So not only is this a big issue, but the solutions that are out there today to try to solve this issue are very costly. They require a lot of human labor and often don't even really solve the problem. So we at Sientis have made it our mission to try to solve and transform this warehouse inventory visibility problem with the use of autonomous drones. We have autonomous drones that navigate these warehouses and are able to scan this warehouse space 30 times faster than any human can, and do it far more accurately. That's just the first piece of the problem, the data acquisition, but there's an entire second piece, which is now that we're collecting so much data from this warehouse, how do we use different types of ML and AI tools to analyze the data that we collect and actually give useful, actionable intelligence, inventory intelligence back to the warehouse managers and warehouse workers? with this, we aim to completely eliminate stock discrepancies in warehouses and actually optimize the entire warehouse inventory process. Let me quickly go over some of the main value propositions that Sientis brings to this space. So first and foremost, we aim to shrink the costs and allow our customers to realize a significant return on investment. Cost reductions happen both in terms of reduced amount of labor that you need to go around scanning the warehouse, and also just reduced amount of cost stemming from lost products. You don't have to reorder everything again. The second thing we do is provide accurate and reliable counts and locations for the inventory in the warehouse. That means we can tell you not only how much inventory do you have exactly, but where is that inventory located in your warehouse at any given time. Finally, we provide up-to-date analytics to help these warehouse managers make better decisions. For example, it allows them to optimize the utilization of the space of the warehouse. And space is basically the most essential asset to a warehouse. So the question we get asked when we try to do this the most is, why are you guys using drones? Like, why drones? And why now, right? Someone before also spoke about the importance of being able to give something useful to your customers within this 2-3 year window. And to answer this question, let's just look at the warehousing space, right? Most of the warehouses in the US have very tall racking. We're talking 25 feet, 35 feet tall racks. You need a power forklift to reach up there. And the warehouse dimensions are also huge, 100,000 to 800,000 and even beyond that. That's a massive 3D space that you need to scan every single day. So it turns out that drones are actually a fairly efficient way to scan such a huge space. On top of that, drone technology has been slowly maturing. Most of us have witnessed a drone, played with a drone, spent time with someone who was playing with a drone. And what this means is, as this industry gets more mature, we are able to achieve long drone time. Like the drone can fly for long hours, and in addition to that, it achieves very stable flight. And as a cherry on top, computation has become very powerful, but also very small. So that means we can put a lot of edge compute on board the drone itself, even though it's a very tiny device. And the actual drone is there in the back for whoever wants to come at the end to look at it. Another interesting aspect that we find is that it's actually fairly easy to incorporate a drone into the day-to-day life of a warehouse worker. Think of it as simply replacing the extremely expensive forklift and handheld scanner with a drone and a tablet, as long as we define the human-robot interface well. So how does a day-to-day operation of Sientis actually look like? The warehouse worker would take his tablet, select the area of the warehouse that they want the drone to scan, click a button, the drone takes off and scans the entire warehouse autonomously. The worker doesn't have to do anything, doesn't have to look at the drone's on its own going to each bin location. As the drone visits each location, it's able to capture image data, other sensor data, and pull out all the information from each bin that it visits. After the drone lands, all this information is then sent to our edge compute, where we actually pull out all the useful information about inventory, such as barcodes, optical character recognition, box counts, and even features of the products. And finally, all of that information is then sent through our AI-based inventory analysis software, which is able to figure out the trends and what's actually happening with this inventory, what's lost, what's found. And we present all of this to our customers with a very user-friendly interface. A few of you who have been exposed to warehouses can probably attest to the fact that the systems that they use are pretty dated. It's not colorful. It's not fun to use. This provides these warehouse workers with a much more user-friendly experience, and they can see exactly what's the state of the inventory in their warehouse at any given time. In fact, from their desks, they can go and click a button and see what's exactly in a bin without having to walk out into the entire giant facility. I'd also like to give you a brief overview of the technology stack that made all of this possible. And it starts off from the fact that Sientis has its roots in Nokia Bell Labs. Nokia Bell Labs is a historic research organization in the United States which has over 10 Nobel Prizes and actually celebrated its 100th year this year. So most of our researchers come from Nokia Bell Labs, and we bought with it our own patent a custom, unique software, especially in the field of computer vision, which allows us to navigate and localize in these large warehouses with zero infrastructure changes. So we can go to a new place and not have to put up any tags or any other type of things. We are able to completely fly autonomously in completely new spaces. On top of making our algorithms very performative, we've actually spent a lot of time trying to make them efficient so that all of the core autonomy algorithms actually sit on the drone. The small compute on the drone is able to handle all of the compute that the drone needs to navigate. And what this then enables us to do is to fly without any requirement for network. So if a warehouse doesn't have Wi-Fi all over, that's totally fine with us. Our drone, once it takes off, can handle everything all the way up to its landing. We only need a network to offload the data from the drone. So finally, that's the drone data acquisition piece. But of course, from the customer's point of view, the true usefulness comes from the information, the data we gather. We now use a lot of AI-based, LLM-based tools that allow us to really extract all the useful intelligence and tell warehouse workers, what can you optimize? What's actually happening to your product? What product's getting lost the most? All of these little things that allow them to optimize their entire warehouse processes, and on top of that, minimize all of their costs. So we at Sientis are committed to bring clarity you can count on to the warehouses of today and tomorrow. Open to any questions. Thank you.
Hi, great presentation. Thank you so much. I happen to have worked for another startup in California called Wandercraft that does cycle counting and warehouse management systems. So one of the things I will ask, because you said that you are able to provide real-time feedback on how things are done, how often do you end up flying these drones?
That's a great question, and honestly, the answer is it really depends on the customer. There are different customers who have product moving at different velocities throughout that warehouse. So for a customer who has very high moving product, let's say in a section of this warehouse, we're willing to customize the system so that that part gets scanned every night, or sometimes even every 6 hours if that is what they want. So it's a fully customizable system.
All right, thank you.
So great presentation, interesting. How do the drones actually read? Is it radio frequency, optical? How are they actually taking the inventory? And what kind of hardware is on the drone? And what kind of software and AI do you use? What's the stack? Is it NVIDIA or is it someone else?
Awesome, that's a very loaded question. A lot of questions inside that question. So we're heavily vision-based. You'll see the drone in the back. It's got a bunch of cameras on it. So a lot of the data is extracted just purely through images. We do have sensors like time of flight, which can get depth sensing information at a higher accuracy. And as software goes, it's a proprietary autonomy stack that we've built in-house that enables us, and that's our secret sauce, that enables us to localize and navigate inside these large 3D spaces without needing to add any type of infrastructure. Feel free to come back there and we can discuss a lot more, because I can like wax poetic about our software, but that'll take a long, long time. Thank you.
Hey, great presentation. Coming from a logistics background, I've noticed quite a bit of technology in this space. Other competitors like Gather or Dextery. So, how is Sientis essentially trying to stay competitive in this front?
That's a very good question. And as with all of our presenters and robotics, it's a huge space. It's growing rapidly. Everybody wants a piece of the pie. And the good news is that the robotics penetration in the market is not huge right now. It's a very, very big pie that can be shared by a lot of us. We do work on differentiating ourselves in how the product is positioned and what type of customers you try to go for. And it's possible that our product is for a certain set of customers and other products could be for others. We cater specifically to customers who want us to directly integrate with their systems, who don't want to make big infrastructure changes. They don't want big structural changes to their warehouse. Ours is basically a very user-friendly system, which we could go to a brand new warehouse, do a couple of tests, collect a couple of data, build the maps that we need to build, and be ready to fly. So we find different ways to differentiate ourselves in this space, and the space is so large that it's never actually been a problem for us. Yes.
Hey there, I got a question for you. What if they crash? And if, let's say, there might be a reason for them to come down from flying, would they go to the ground or like holster themselves on the wall or something?
So that's an excellent question, and that is the problem with drones, right? Like a lot of the other robotic systems, if something bad happens, you can power off and it'll stay where you last left it. With a drone, if something bad happens and you power off, it smashes to the ground. Not ideal. So a lot of our work goes into building robust systems where there's actually layers of redundancy built into the system. So for example, if the primary vision sensor fails, right, and the primary tracking algorithm suddenly stops, we have other layers of algorithms that then kick in, and even though they're not able to like perfectly navigate in the space and complete large missions, they're able to at least bring the drone down safely to the ground. So we have layers on layers, both from hardware redundancy and software redundancy, to make sure that if something fails, we A, detect it as fast as possible, and then B, switch to safety systems that allow the drone to land.
Last question. Hi, you mentioned that one of the advantages of having the computing on the edge and some of the data storage on platform is if there are warehouses that lack Wi-Fi. I can't imagine that in much of the developed world it's that hard to slap a Wi-Fi router on the wall of a warehouse, and given that therefore that there's probably not much of an addressable market in the developing world of warehouses that are so poor that they don't have Wi-Fi but they would be willing to buy a drone. What's the actual advantage of having the compute and the data storage on the edge?
Yeah, interesting question. So the thing there is, yes, most of the warehouses try to provide Wi-Fi throughout the warehouse, but warehouses are spaces which are very, very like complex for a Wi-Fi. It's metal structures with a lot of dead zones. And if you have like compute, like you're talking about a drone that has to precisely localize itself and understand its exact location in the warehouse constantly. It's operating at frequencies like 30 hertz. If you hit a dead zone even for 2 seconds and you're actually reliant on talking to someone outside, you're done. So for us, being able to not have any of those requirements and have everything on the drone, and this means even machine learning models, everything running on the drone, means that we can not worry about this problem at all. Because in our space, unfortunately, robotics to really make it, we have to try to promise our customers that our failure rates are going to be really, really low. And it's just not acceptable for us to go to them and say, hey, sorry, your Wi-Fi was choppy in this area, the drone went down. So yeah, we try not to get into that situation if possible.
Thank you, Nash.
Thank you.
Paul, how do you do? All right? Okay. Next up is Ross Blum from Skyline Robotics. Hi, I'm Ross Blum, President and COO of Skyline Robotics. This weekend, my son got really sick, and I woke up this morning feeling the same thing. So I'm not going to go through my whole presentation today, but I will share a video with you that talks about what Skyline Robotics does and how we're advancing the future of facade management. I think that's their tagline. Thank you, Ross. Randy, what is the name of the building? Is it the Hearst? Durst? The system's currently being installed. It should be up and running again because they're in a cleaning cycle, so you can actually go see it live in Manhattan. I don't know the address. I don't know. So keep an eye as you're walking around through Manhattan. Look up and you might see some robots above your head. All right. Last, we'll have him walk in, Matthew from Wandercraft.
Hi, everyone. Since we began Wandercraft, we've been on a mission to offer a new option for everyone who wants to walk again. And the way we did that was by building an exoskeleton, which you may think of as a humanoid robot that allows someone to use the legs off. And it's been quite a journey. The person that you see here on the screen, actually here on the screen, is Kevin. He had a motorcycle accident, and using one of our devices, he was able to carry the Olympic torch during the Olympics in Paris last year. Quite an amazing moment for the company. And so, yeah, I just want to, we're going to skip this. Our products are live in over 100 institutions worldwide, which is how we've been able to help thousands of patients to walk again and again. Millions of steps taken every month. And today we are talking about physical AI. To us, physical AI is about using the data that we've accumulated to make the most efficient bipedal platform to walk again. So what does that mean practically? So my team loves that slide because they get to push me. It means that you're able to use the data that you've built and you've accumulated to make the device more and more stable and better at locomotion and getting and handling perturbations. There are a couple issues when you do physical AI. You can do a lot of simulation. You can do synthetic data. And we do that a lot, billions and billions of simulation to learn how to walk and to move. And in practice, you get, you can get to a good level of performance. At the beginning, you're going to fall a lot. But as the iterations go by, you get to a pretty good level of performance. So, of course, you have to go through all the flukes at the beginning. But we'll get there. The issue with that is as soon, and I'm sure a lot of people do robotics in the room, as soon as you put that on a real-world device, typically nightmare happens, and the device. There was a video a couple days ago or a couple months ago where a robot is starting to kick everywhere, and that's kind of scary, right? And so in our view, one of the biggest issues with physical AI is to bridge what we call the sim to real gap. So how do you get something that works in simulation to work on a device that you're going to deploy live with people? And we've talked a lot about that, all of us today. I think that's one of the huge challenges. And the way we solved that was a subtle cursor where you have to do simulation, but your simulation has to be complex enough that it represents the real world, but not too complex that you cannot run it very, very fast, very quickly. You still have to do the billions of iterations, but each iteration has to be very fast because you have to be able to compute a lot. And accumulating all that data over all those devices, this is the level that we've managed to get to. And what it translates into is a very, very, very efficient way to stay upright, which is very important when you're trying to move around. Of course, we would never do that to a real person, and so they asked to do that on me, so I refused. But what it allows is that level of performance where the device is going to be able to move the same way a human being would move when pushed around. You see the way the foot is going sideways. This is really a learned behavior that you wouldn't be able to code. And it also allows you to get speed that are, I think, unmatched in the industry, which is very important because if you want to do something that works everywhere, you have to get to a certain speed. And we were able to do that not only with those dummies, but with Thibaut, who is the brother of my co-founder. So the reason we created that company was because we had people in our family and entourage that had mobility impairments, and we wanted to provide that option to them. And what you see is a person that is weighing probably 180 pounds, so very, very heavy payload. We've been talking about heavy payload all that time. We have a platform that can carry those kind of payload, not only here, but everywhere. We came to the US a couple years ago, and we've opened a place here in New York, which we call Walk in New York. It's 12 blocks north from here, Park and 26. And we're happy to help every person, whatever their place on the mobility spectrum, to walk again in our offices. We didn't bring a device today because we want you to come to our place to try and test the device. And we've had people who were everywhere on that spectrum, from people who cannot walk at all to people who had some walking and others who were on their journey to strengthening or restore their walk. We'd like to say every step counts. We really believe in that. So if you know anyone that can benefit from that, want to benefit from that, please reach out. Because too many people believe that this is something that is 5, 10 years away. This is something that is right now. Thank you very much.
Thank you very much for this important work that you're doing. So how does this work for physical therapy or rehabilitation? If someone's in a hospital setting, do they have to come to your center, or is this be able to be deployed in hospitals?
Yeah. So we are right now, as we speak, in over 100 hospitals doing physical therapy for all these patients. So we do both. We have our own place, which I call Walk in New York, but we're also in most of the major health systems, both in Europe and in the US. And so the way it works is we train physical therapists to use and operate the device, and then themselves can provide walking sessions to their patients as they come and want to benefit from that. And that's how we 10x our impact, because we wouldn't be able to touch all these patients just ourselves.
Amazing work. Are these commercially available, and what cost? And then also, when you train them, do you use like Isaac Gym and Isaac Sim from the NVIDIA stack?
So the device is commercially available. We are selling it, or we have other models, to all the major hospitals out there, and also the smaller ones, because everyone has to have that option. The personal device that I just showed, which is going out there in the streets and people can bring home, will be available as soon as next year. And something that people don't realize, and to your point of affordability, Medicare is paying for that device for patients at home. So the device will be widely available, and we're building a community of people who want to benefit from it as soon as it is available. Affordability will not be an issue. To your second point of NVIDIA, so we are proud. We were on the phone with NVIDIA just earlier. We are really good friends with the NVIDIA team, and we're using both some of their chips, so Jetson, and also benchmarking their simulation capabilities against, I wouldn't say our own, but we've built an open source simulator, which is called Gemini, that is pretty good at what it does, and so we're basically using both.
Hi, I have a question about the human interface here. How does the person control the exoskeleton, and also what happens at the intersection of one's own sense of balance versus the sense of balance the exoskeleton AI has?
So the way to control the device, I think in the disability space, what you learn is that every person has different needs and has different strengths. We have a number of interfaces depending on what the patient needs and want to use. The main one is through essential inertial measurement units, IMUs, that are on the back of the person. And so that way, when you lean forward, the device will understand that you want to move forward and sideways, and so on and so forth. We also have, obviously, joysticks that are very easy to use. That's one of the main interfaces on powered wheelchairs, for example. So most of our users are used to that. And we've been experimenting with some other stuff. We see a lot of cool things happening in the BCI space. Obviously, one of the main applications would be to control such a device. I know a lot of people want to make quadriplegic people walk again through that kind of interfaces. We're already doing it and have been doing that for quite some time. So we try to provide the largest number of interfaces because, again, everyone's needs are different, and we try to take that into account.
Thank you so much for your presentation. Since I have a family who have a mobility challenge, it's very impressive. I have a question for if the users want to drive or want to take a transportation. I'm curious how it will work.
It's something that we get a lot. People with mobility challenges have developed their own ways to go around and move around, and what we hear is that for a lot of them, their car or other things are very important to them because that's how they've learned to navigate the world. And again, we need to accommodate that. The goal is to make the device compatible with all transportation, and ideally, we'll try to make it compatible with getting inside a car, which is important for us. It will require a little bit of miniaturization, so getting the device a little slimmer. But we've already made some testing, and we're able to get into large vans with the device. So we're quite confident that mid-term, it will be possible to get inside such vehicles. Thank you. Thank you, everyone.
Okay, well, listen, a huge round of applause for everybody and all the innovation. And a big round of applause to Jacob for pulling this all together. What an incredible lineup. Jacob, thank you so very much. All right, we are going to take a few minutes. This is our community Ask Offer segment, and I'd like to invite anybody up to the stage to pose their own ask to the community here. You have 30 seconds each, okay? So anybody, would you like to come up and ask? Okay, come on up. Come on up. All right. Wherever you'd like.
Hey everyone, I'm Natasha Green, CEO and founder of Hidden Gems Archery. We are a mobile archery business that helps adults and youth not to be aimless. I am a techie, so I am here for a reason. You can check my laptop out. But my big ask is I'm trying to do an adult archery sort of tournament where it's a fun day of learning how to shoot, but then we have prizes at the end. So if you are interested, follow Hidden Gems Archery. You can follow us, you can find me, and if you want to take your shot, join us. Thank you.
Hello everyone, Michael J. Frank. I am a co-founder with two millennials of Gilder. We are an international knowledge community of founders. We're in 25 countries. We have about 270 people. And we more recently offered our community in a box for venture firms. Happy to say hello to anybody and happy to offer a discount for anybody who'd like to become a member and participate.
Hi everyone, my name is Georgianne Gatton. I am the CEO and founder of GSD Solutions. We're a B2B technology advisory firm. We're also a partner for the New York Tech Alliance, and I'm a board member. We did a little raffle earlier, so I wanted to offer who won the raffle, so I'm picking a random business card. We have Neon Labs, John. Okay, all right, chat to us in the back, so John, you're the winner. But I wanted to see by a raise of hand, who's here because of New York Tech Week? All right, well, so shout outs to kicking off New York Tech Week, but I wanted to say that every month here we do the New York Tech Alliance, the monthly meetup. So if this is your first time, I saw the hands earlier, make sure you tell a friend and come back next month. We do these every single month. Stay on our website, a lot of really exciting things are coming on. We recently announced the Civic Hall, the Bernard Center, so just please keep participating, tell a friend, share on social, but we really appreciate your support. So thank you.
Mic one. Hi, my name is Stefan Henry. I'm CEO of a company called Level the Curve Incorporated. What we do is we make adaptive tools for people with disabilities in general. We also help consult on adaptive devices. So anything from like eating tools, cooking utensils, things to help out the community. We're all for it. I'm actually really up here to just tell you guys about us a little bit. Hope you guys come check out our website. We are actually hosting an event in July. It's an event for all artists with disabilities. It'll also double as a fundraiser for our company. I welcome you all to come.
Stefan, what's the website address?
www.levelthecurve.com.
Hi everyone, my name is Jose Garcia. This is purely for community sharing. There's a community called the New York Hardware Meetup that always seeks speakers. So for some of the presenters here, feel free to consider presenting there, particularly the one that was about the open source, trying to share that. And then also the New York City Office of Technology and Innovation offers an initiative called Testbed, where they will test out your technology for city adoption. So if anyone's not familiar with it, look up OTI Testbed.
Thanks, Jose. Okay, we'll take 1, 2, and 3. Okay.
Oh, I'm not offering myself. I'm offering my friend Sam for his services. You know, someone needs to be like the pusher in their life. Sam has always been the pusher for my life, so now it's my turn to return it. And he has this cool product called Fireflies AI. If you can benefit from a note-taking assistant, he's your guy.
Thank you. Yeah, so Fireflies is the note-taking AI. It might be in your Google Meets or your Zoom or your Microsoft Teams. In meetings, you can use it to get notes. And one of the things that we're doing is bringing Fireflies to life. So it's going to start speaking and engaging in meetings and eventually inhabiting robots like humanoids. So yeah, thanks. Feel free to try it.
Thanks.
Hello, hi, I'm Srijan. I'm working with this company called Omi, and we're building AI hardware, and we're building it all open source. So this is a pendant that we're building. It transcribes everything, you know, that someone is speaking to me or I speak with them. So especially useful for conferences. And we launched, you know, a couple of months ago. We're live. This is how the new product looks. We're also launching, you know, smart glasses directly competing with Meta. And the most interesting thing is we're launching the industry's first dev kit for brain, vision, and audio dev kit on June 25th. So keep an eye, omi.me, omi.me. Follow us and check us out. Thank you.
Thank you. And last one.
I'm the last one, and what a lovely community we have here. Today has been a great event. I'm gonna keep it short and sweet. AI is becoming more and more topical, and I have the goal to go and dive deep in these conversations. I've started my own podcast called Double A Media, and if you guys are interested in AI, you wanna hear professionals' advice, and you wanna dive deep in these topics, Double A Media is the best way to gather your information. On the other hand, if you feel passionate about your startup, you want to share with the world what you're building like we saw these people build here, please reach out to me. I would love to pick your brain, and I would love to share to the world how much power you have in your own work and in your own use case of AI. Thank you for your attention.
Okay, and let's see, that's it for that. So our next meetup is on Monday, July 14. We'll be partnering with the New York Supply Chain Meetup, and it's all about moving the world, tech and the global supply chain, all right? So we hope to see you there. And with that, that's it, guys. Dropping the mic. The bar is back open. The food is back open. Help yourself and connect, okay? We'll see you next time. All right. Oh, can we get a group shot? Guys, can we get a group shot?